Good morning, good afternoon, and good evening. This is a tutorial on Web 7.0, mostly targeted at a non-technical audience, but I think most people will get a fair bit of knowledge and understanding about what Web 7.0 is all about by watching this tutorial. My name is Michael Herman. I'm a self-sovereign blockchain architect and developer. I live on a farm in Calgary, Alberta. Those are some of my cows. You might wonder, what does that have to do with digital identity and decentralized systems? Well, there's actually quite a few relationships there. It ends up being quite an interesting laboratory, if you will. As I work on these slides and record these videos, this is the view from my office window, one of the most beautiful parts of southern Alberta. Just before we kind of get into the meat of things, I'll just want to say a few words about the concept of first principles thinking. I'm by nature, it took me a while to figure this out, but my very nature is to be a first principles thinker. This means I just have a natural tendency and intuition to break complicated problems down into their most basic elements, to decompose them into their most basic elements, and then synthesize or reassemble them from the ground up. And so here you see in Web 7.0 a lot of concepts and technologies drawn from a bunch of different areas, put together perhaps in slightly unique ways, perhaps in ways you've never seen before. I don't really apologize for that, but I wanted to make you aware of that up front. Web 7.0 has a mascot, so I'd like to introduce Freddy the Frog. And if you have any questions at any time about Web 7.0, you can go to Twitter and send a direct message or a tweet to @FreddyArchitect, and Freddy will do his best to answer any and all of your questions. Okay, so the agenda, we're going to kind of introduce a little bit of the background and where the concept of Web 7.0 came from, the concept of trusted personal agents and how they work together, a little bit about credentials, about the Internet Credential Architecture Reference Model, or intercredentials, as we call them. And we'll say a few words about the Web 7.0 white paper if you want to delve deeper into the topic of Web 7.0. And finally, we'll have some concluding remarks. So a lot of the roots of Web 7.0 have to do with a product created 20 years ago by Ray Ozzie and his team at Groove Networks. It was called Groove Workspace, and it was a peer-to-peer group collaboration tool that ran on Windows, Microsoft Windows, and it supported disconnected clients, people that were working behind firewalls, or maybe you wanted to send them a file or a message and they weren't online at that particular time. It was completely decentralized system, mediated by some central servers to support things like disconnected use. So you'll see a lot of the vestiges of what went into the Groove product built into Web 7.0. Parallel Space at the time was a founding Groove Networks business partner, and we're the most prolific developer of business solutions for Groove. Little more recently, was it 2018, 2019, I was giving a keynote presentation at the first Turkish International Blockchain Workshop, and I presented this idea that if we take something like the ERC or NEP 5 token standards, ERC 20 is the token standard for Ethereum that says this is what you have to do to transfer a token or an ether from one person or one account to another account to another account. I didn't see a lot of business value in that, honestly, but I came up with this idea that what if there was different kinds of tokens? What if you could have a token that represented an expense report or a timesheet, some sort of contribution report, and that you could submit that to the smart contract, have a workflow running that could adjudicate that expense report or timesheet. If it was below a certain level, you might automatically get paid. If it's say between $100 and $500, maybe it gets routed to an accounting clerk. And if it's over $500, it has to go to your manager for approval or rejection. And so being able to take the simple concept of transferring value in ERC20 or NEP5 and supporting primitives like create and submit, approve, reject, reroute, and then finally pay. And you'll see aspects of that concept built in all through Web 7.0. The intermediate project, in fact, really the parent project for Web 7.0 is something called the Trusted Digital Web. And that's where I took those concepts I talked about on the previous slide and said there's really 3 points on the triangle that we need to integrate together into a fully integrated experience. The idea of decentralized currency, on the right, decentralized or universal digital identity, and in the middle, decentralized workflows. And it's the culmination of these 3 aspects and the refinement of those that have given us Web 7.0. This is a diagram from the Computer History Museum in California. And the point of this diagram is to illustrate the difference between the internet, this thing called the internet, and this thing called the web or the World Wide Web. So the internet is a communications network, a global communications network that connects our devices together. It connects our laptops to our tablets to our phones. And it's that base level communication layer. If you take your right hand and hold it in front of you, think of that as being the internet. Hold it flat. Place your left hand on top. That thing that you're putting on top is the World Wide Web. It's an application running on top of that global communications network. And the purpose of the World Wide Web today is to connect people to centralized web servers and websites. And so we can see here, people not really interacting with each other, but interacting with these centralized resources like Google Mail, like Facebook, like all the Apple services. And there's a problem here because all of those large corporations control your identity. You provide your user ID and password, but they create an identity in their systems that they're able to turn on and turn off. They're able to attach history of every place that you visited in their site, and they're able to sell and remarket that data, and you have no control over it. So this is the centralized world that we're trying to address in Web 7.0. If we look at Web 7.0, adding that third diagram on the right, it's not about connecting people to centralized servers. It's about connecting individuals with each other and literally connecting people with each other through their trusted personal agents. So a personal agent, a trusted personal agent, is a piece of software that runs on your phone or perhaps on your computer at home. And your trusted personal agent interacts with other personal agents. So Web 7.0 is about connecting individuals to each other via their trusted personal agents, and we'll dwell on that quite a bit. Here, we're looking at a little bit of kind of a building block explanation of the old web, the old World Wide Web in purple there, and the new Web 7.0 in green. At the bottom is the internet, that global communications network. And on top of that, we can see our devices, our smartphones, our personal computers, big servers, Internet of Things devices, etc. And traditionally, in the World Wide Web, version 2 or version 3, the components are web servers and web browsers. Web browsers running on your personal computers talking to these centralized web servers. And they're using protocols like HTTP, and they're returning things like web pages and images and web data. The new world of Web 7.0 on the right is focused on having your own personal, trusted digital agent. And we see that in the middle of the green box. The protocol here is called Didcom. It's what one trusted personal agent uses to talk to another trusted personal agent in a secure and private means. And they exchange, those trusted personal agents exchange something called DIDComm messages. Those DIDComm messages can have something called verifiable credentials, which is verifiable data, trusted or truthful data. And the way that people and software components and data is all identified in Web 7.0 is using something called decentralized identifiers, or DIDs. Just to emphasize the difference between the old web and Web 7.0, there are no websites in 7.0. Websites are centralized concepts that are part of the old web. They have no place in the new decentralized Web 7.0. So what's the elevator pitch if somebody says, what's Web 7.0? Web 7.0 is a unified software and hardware ecosystem. It's a unified software and hardware ecosystem for building resilient, trusted, decentralized systems using decentralized identifiers, DIDComm agents, and verifiable credentials. Web 7.0 is a unified software and hardware ecosystem for building resilient, trusted, decentralized systems using decentralized identifiers, DIDComm agents, and verifiable credentials. It builds from a whole bunch of different specifications, a whole bunch of different specifications organizations, and that leads to the tagline there at the bottom: take what you need and leave the rest. So in Web 7.0, it's trying to be exactly what it says in the statement. It's not trying to be an amalgam of every possible decentralized technology. We've taken what we need and we've left the rest. Similarly, if you're building resilient, trusted, decentralized systems, it doesn't mean you have to use everything that Web 7.0 has to offer. So in the same way, Web 7.0 borrows from other initiatives and leaves the rest. If you're building applications, you don't have to use everything that's in Web 7.0. You take what you need and you leave the rest. Here's a simple use case. I'm not going to go into all the technical details, but on the right we have Dr. Carroll, cardiologist office in the green box. And Dr. Carroll has a medical record system, running on a personal computer. And on the left side in the blue box, we've got Gina, general physician. Well, Dr. Carroll, cardiologist, when she sees a patient, she makes copious doctor's notes on a patient-by-patient, visit-by-visit basis. Today, fax is still the most common way of distributing those patient's notes, those doctor's notes, to the patient's general physician. And so we're showing here an example of a decentralized system, a decentralized solution built using DIDComm, built using DIDComm agents, and built using verifiable credentials. We've talked a little bit already about trusted personal agents. Trusted personal agent, it's your personal software agent. And when we're drawing pictures of these systems, when we're creating architectures and designs, we have a visual language that we use called DIDComm notation. And what you see here on this slide is a depiction of a trusted personal agent, a DIDComm agent. It's a DIDComm agent representing a person. You see the little person there in the top left. And the way that trusted digital agent talks to other digital agents is through those purple boxes at the bottom. And so we can build up. Here's a simple design. Here's ABC Grocery on the right. ABC Grocery has a DIDComm agent. On the left, we have David's Cabbages, and David's Cabbages has a DIDComm agent. And what we're illustrating here is that ABC Grocery wants to issue a purchase order for 10 cabbages. ABC Grocery wants to buy 10 cabbages from David's Cabbages. So at the bottom we see one of these verifiable credentials, a purchase order that's represented in a special format, and it has what we call a signature or a proof, so that when it is sent from ABC Groceries software agent over to David Cabbage's software agent, David can be absolutely certain that this is in fact a purchase order, that it hasn't been manipulated or changed in the process of being sent from ABC Grocery to David's Cabbages, and and David can also be ascertain that it is actually ABC Grocery that sent it. We're not going to go into all those kind of technical details in this little tutorial, but this illustrates how we use DIDComm notation and how we can build up DIDComm-based systems using DIDComm agents and verifiable credentials. Here's kind of an illustration of what that purchase order represented as a verifiable credential. Some of the information it might have it. On the left is the DIDComm notation that we use for a verifiable credential. And if we actually wanted to see an example verifiable credential looks like, this is what it looked like. It uses another computer language called JSON, and if you look inside the green box, you can see there's a purchase order number and a from and a to and an invoice line for the 10 cabbages at $1 each, and this is the information that is transmitted in that secure, private, encrypted way from ABC Grocery over to David's Cabbages. At the bottom of the verifiable credential is this proof, this mathematical computation, this additional piece of data that's added to the verifiable credential, so that when this whole object, this whole piece of code is received by David's Cabbages, David's agent is able to ascertain that whether this purchase order has been tampered with, and also to discern exactly who it came from. Just as another example, here's a credential representing a driver's license. So not only do credentials have a JSON representation, but they will also have a visual representation like we see here. And so we have a person, Erin Amanda Jane Anderson, and this is her operator's license, her driver's license from a fictitious province called Savronia. We'll talk a little bit more about credentials, but in Web 7.0 we've been able to generalize the concept of a credential, and we call it an internet credential, or inter-credential for short. And that's what you see depicted here, and this is what we use throughout Web 7.0, internet credential. This eye chart just shows you how all these different DIDComm communications elements fit into what we call the hourglass, the trust spanning layer framework. This is really all about security. We want all communications, regardless of the type of communications that happens within a DIDComm network, to be funneled through this DIDComm language, this DIDComm communication system. And that way we're able to assure or have a better sense of how and when and why that all communications in Web 7.0 are private, trusted, and secure. This kind of, again, another eye chart, but this is the overall Web 7.0 software architecture. And so it's using DIDComm notation here to show a couple of different kinds of agents and how messages can be routed around. And it's a very sophisticated and complete, it is unified. A key word here is that we have a unified model for how agents talk to one another, how they talk using this DIDComm communications protocol, and how that DIDComm communications protocol represents a trust spanning layer, a single narrow protocol through which all communications can pass and help to guarantee the security, privacy of everything that is exchanged between two agents. If you want to know more about Web 7.0 and the Didcom agent architecture, there is a white paper, the Didcom Agent Architecture Reference Model, or Didcom ARM. Its goal is to be a design guide for software architects and developers. The primary purpose of the Web 7.0 white paper is to be this guide for software architects and developers designing and building Didcom agent-based systems. The goals for realizing that purpose are to better understand the active components of a Didcom agent-based software system and how these components rely and interact with each other, to introduce that graphical modeling language that we've seen snippets of, the Didcom notation, to aid architects and developers in visualizing new architectures and designs for these Didcom-based systems, and to describe a layered reference model, the Didcom architecture reference model, that helps architects and software developers in the design and creation of the broadest range of Didcom-based software systems possible. The white paper is about 80 pages. You can find it at hyperonomy.com. Hyperonomy.com. It is the topmost article that is pinned to the hyperonomy.com website. So that's a fairly quick walkthrough of what Web 7.0 is. Let's just recap. So again, the elevator message, Web 7.0 is a unified software and hardware ecosystem for building resilient, trusted, decentralized systems using decentralized identifiers, Didcom agents, and verifiable credentials. And the byline is, take what you need and leave the rest. The core element, the core concept in Web 7.0 is a trusted personal agent. Every person on the planet will have a trusted personal agent. Anything of value will likely have its own trusted personal agent. A car, a large piece of machinery. Companies will have hundreds or thousands or tens of thousands of trusted personal agents. But the primary focus is connecting you with your colleagues and friends, business acquaintances, and having your Web 7.0 trusted personal agent being able to act on your behalf, being able to receive messages, being able to send messages, being able to receive documents as verifiable credentials, being able to act on those documents in a way that you prescribe. We've looked at a simple example where ABC Grocery is sending a purchase order verifiable credential across the Didcom network to David's Cabbages. And we had to look at what that verifiable credential looked like, the code for that verifiable credential. And the whole idea of Web 7.0 and the Didcom network is to provide secure, private, trusted communications of any information from a sender to a receiver, from ABC Grocery to David's Cabbages. We saw this picture of the whole Didcom network, the whole Web 7.0 architecture. And this is easily scalable to billions and billions of users, billions of companies and organizations, schools. Anybody will be able to participate in this decentralized ecosystem. We briefly saw the trust spanning layer framework, the Web 7.0 trust spanning layer framework. And we can see the skinny part of the hourglass there labeled the trust spanning layer in green. That's where the lowest level foundational elements in layer 1 are funneled through the Didcom protocol, the Didcom messaging protocol, to be made use of by those higher level concepts such as verifiable credentials and and the Didcom agents and Didcom user agents. In the elevator message, it said that Web 7.0 is a software and hardware ecosystem. This is an example of the Web 7.0 always-on Didcom agent. Most people will interact with Web 7.0 and the Didcom network using their phones. They will have a Didcom user agent running on their phones. But as much capacity as our phones have, you can't expect a phone to be able to store our entire lives. Or if the Didcom agent is acting on behalf of, a Microsoft or Google or Apple, you can't expect, a Didcom user agent running on a phone to be sufficient for a large corporation. So there is the concept of the Didcom always-on Didcom agent, which is a hardware appliance. It's a hardware appliance that runs the Didcom agent code. It has a workflow engine. It's able to download and run business workflows. It's able to receive Didcom messages that have verifiable credential attachments and act appropriately to invoke the appropriate workflow based on the type of the incoming message and the incoming attachment. We talked briefly about verifiable credentials, or the more generic version called internet credentials or intercredentials, to support authenticated, secure, private, trusted data in Web 7.0. Driver's licenses, purchase orders, invoices, way bills, delivery confirmations, all of these are part of the elements that make up the trust layer within Web 7.0. We have a specific technology adoption model in mind. This one is from the Harvard Business School. It talks about a particular path or strategy for product evolution. Again, I refer you to the hyperonomy.com website to learn more about Model 3, the phases of foundational technology adoption. Web 7.0 is going to be supported by a formal collection of standards documents, of standard specifications. What you see here across the top is the same model that's used for the Linux operating system. There's what's called the standard base specification set, the top left-hand corner. And it is comprised of the common core and then protocol-specific documentation. So the common core is specifications that will apply to every instance, every distribution, every implementation of Web 7.0. That's the green Jaguar. The purple Jaguar represents the protocol-specific components of Web 7.0. For example, the most prominent protocol that will be used in Web 7.0 is the Didcom communications protocol that we've been talking about, and more specifically Didcom running over the HTTP web protocol. And so we get a series of documents on the right-hand side of this slide, a special instance of the trust spanning layer framework specifically tuned to Didcom over HTTP. That's going to reference other specs such as the Didcom network spec and the internet credential architecture reference model. In yellow or gold on the far right-hand side, we need tools to enable developers to be able to build trusted digital agents. So there is the Didcom Superstack, which is a set of tools, not the only set of tools, but it's the primary set of tools that can be used and have been tested and proven to work together for rapidly creating Web 7.0 Didcom agents. So if you have any questions, I encourage you to tweet them to Freddy Architect on Twitter, either a direct message or a general tweet. Freddy's waiting, he'll answer them, and we look forward to hearing from you. And that brings us to the end. So I hope you've enjoyed the last 30 minutes and found it informative. If you have suggestions for improving it, if you have suggestions for Web 7.0, if you have ideas for how Web 7.0 can help you, please feel to reach out to Freddy the Frog or myself personally. Thank you very much.